We take together our advanced financial management. We are taking a certainty equivalent and the investment decisions and conditions of uncertainty. Now, certainty equivalent is the next item, and we are saying that under this method, a coefficient which is a proportion of the cash flows which are certain to be realized, i.e., riskless cash flows, then cash flows which are uncertain, i.e., risky cash flows will be determined and assigned to the risky or uncertain cash flows. The certain or riskless cash flows. Let's move to the next page. Will be discounted. Will be discounted. We are saying will be discounted at the risk-free rate of return as follows. So we'll be taking certain cash flows, you divide by uncertain cash flows. Under this model, risk cash flows are converted into riskless cash flows using a certainty equivalent coefficient. The riskless cash flows are then discounted using the risk-free rate of return as the discount factor. After that, the net present value will be calculated by the present value of the cash flows minus the present value of cash outflows. So present value of cash flows, you'll be taking expected cash flows times certainty factor, then you multiply by risk-free discount factor. Certainty coefficient at the end of year one, which will be very important, will be taking the certain amount, that is the amount that you are sure of, you divide by expected amount. This expected amount you are not sure of. Then after that, that is for year one. So for year one, you'll be picking that amount that you are sure of, the certain amount, divided by expected amount that of risk. Then for year two, you'll be taking certainty factor of year one. Then you raise by 2. 2 is n, the second year. Then you go to third year, certainty factor of year 2 raised to 3. All the way. If it is year 4, you'll be taking certainty factor of year 1 raised to 4. Then after that, having known that, so understand those formulas that have been there, this discussion up to here. Then after that, we can take an example. We can take an example together. Now let's take this example together, whereby we have been told a project requires an initial investment of shillings 500,000. It is expected to generate cash inflows of shillings 200,000 per annum for the next 5 years. Additional information. The firm is indifferent between a certain amount of shillings 181,347 at the end of the first year and the expected amount of shillings 200,000. The risk-free rate of return is 5% per annum. The risk-free rate of return is 5% per annum required. the net present value of the project incorporating certainty equivalent coefficient. Then number 2, advise the management on whether the project is worthwhile. So you can check that question, and then you can take the solution together. Let's see our solution now. Our solution, what you do with our solution is that with our solution, okay, let's go on. The solution that we take the certain cash flows, which is also known as riskless cash flows. So this 181,347 is a riskless cash flow because we are certain that we will generate that amount. Remember here what you have said for year 1, certainty equivalent. For year 1, certain amount, the amount that we are sure of, divided by expected amount. The expected amount we are not sure of. So we will come here, you are taking 181,347 divided by 200,000. The 200,000 are as a risk because we are not certain whether we will generate this 200,000. So you divide, as you have shown here, certain amount divided by expected amount, which means 181,347 divided by 200,000, you get 0.9067. Now this number is quite important. What you do is that you arrange your work this way. Year 1, 2, 3, 4, 5, because this project has 5 years expected life. For year 1, 0.9067, which you have calculated here, then you raise by 2, the same number, raise by 3 for year 3, raise by 4 for year 4, raise by 5 for year 5. Then the answers that you get are here. These are the numbers that you're getting. 0.9067 raised to 1 is this. 0.9, you see this number is the one you have calculated up here. After dividing the certain cash flow divided by uncertain cash flow, this is what you got, 0.9067. So see what we have done here. Raise by 2, raise by 3, raise by 4, raise by 5, you get this. Once you get this, you have another column here for risky cash flows. Risky cash flows, the 200,000, this one, expected amount of shillings 200,000 is risky. We are not sure of generating the same figure. Risky cash flows. And then to get the riskless cash flows, you'll be multiplying this by this to get riskless cash flows. So to get these figures, you are taking risk cash flows times these figures here to get riskless cash flows. So if you multiply 200,000 by 0.9067, you get 181,340. 0.8221 times 200,000, 164,420. 0.7454 times 200,000, you get 149,080. You continue this way. So once you get this, you open another column where you have present value interest factor. Present value interest factor at 5%, 5 years. So 5% is a risk-free rate, 5% for 5 years. So you'll be taking 1 plus r raised to n, negative n. So 1 plus 0.05 raised to 1, then raised to 2, raised to 3, raised to 4. These are raised to negative numbers because you are taking, we are looking for present value interest factors where the rate is 5%, this one here. Then you are raising by negative n, the number of years in question. So once we have done that, we have this column, then you multiply these present value interest factors by riskless cash flows to get the present values. So we have our present values here. So you sum up all this, you get this, and then you less initial capital outlay. Remember, this project cost you are told a project requires an initial investment of shillings 500,000. So you less the present value, total present values which are here, you minus 500,000, the initial capital outlay. And the net present value is 154,891. Ordinarily, we know that projects with positive net present values should be accepted, while projects with negative net present values should be rejected. So as far as our solution is concerned, we should accept this project because it has a positive net present value. A positive net present value means that if you initiate that project, it will increase the value of the firm by the same amount. A negative net present value implies that if you initiate that project, you will reduce the value of the firm by the same figure. So our solution is there. You can just you can look at that example. You can look at the example from there, whereby you are told a project requires an initial investment of shillings 500,000. It is expected to generate cash inflows of shillings 200,000 per annum for the next 5 years. Additional information: the firm is indifferent between a certain amount of shillings 181,347 at the end of the first year and the expected amount of shillings 200,000. So remember that 181,347 is riskless cash flow. We are certain that we will generate 181,347. 200,000, we are uncertain. That's risk cash flow. Then the risk-free rate of return is 5% per annum. Then we are calculating the net present value, incorporating certainty, equivalent, and then we advise. So I have explained everything else, and the solution is there. Finally, we got our answer as 154,891 positive NPV. Now, having that in mind, I think I should give you another. Let me give you a question. I'll give you a question here. Allow me to give you an assignment. I'll give you this assignment, and the solution is just alongside that question is a solution. Just take it. Take your question. You have been told the following information relates to Tripoli Merchants, a private limited company operating in Nairobi but headquartered in Tunisia. We have period 0 to 5. So period 0 means the time when the initial capital outlay was injected. Cash flows 100,000 negative, 255, 467, 149, 589. Certainty equivalent coefficient 1, 0.88, 0.78, 0.94, 0.75, 0.87. The cost of capital is 15% required. Compute the net present value using the certainty equivalent method. Now that is your assignment. However, the solution is there. Can you check that solution? First, compute the net present value using the certainty equivalent method. and you are using the cost of capital as 15%, the solution is just down there. Even though it is your assignment, but there is a clue there about the solution. Now the other question for your assignment, which is still I'll give you the solution down there. The other question for your assignment is there. You are told Kitui County Textiles have a machine with an initial cost of shillings 100 million. This machine was purchased by the county government from Beijing a few years ago. The machine is expected to generate shillings 45 million annually over its economic life of 5 years. The County Assembly, through the Economic Planning and Investment Committee, is indifferent between a certain sum of shillings 10 million today and expected sum of shillings 12 million at the end of year 1. The risk-free rate of interest is 4% required. Compute the net present value of the machine and advise the county government of Kitui So solution, you can see what we have done there. Compute the certainty factor at the end of year 1 to 5. So the year 1, certain amount is 10 million. That is what you have been told. They are telling us that the County Assembly, through the Economic Planning and Investment Committee, is indifferent between a certain sum of shillings 10 million. So certain amount, that is riskless, divided by expected cash flows. What are they expecting? 12 million. This 12 million is risky. So we are taking the certain amount, which is 10 million, divided by the amount that is risky. That is 12. So 10 divided by 12, you get 0.83. Can you guess the next thing that you do? From the next page, why can you attempt first the question before you look at my solution? You can attempt the question first, you finish up, and then you can look at the solution, which I'll give you. Okay, so you take, you have taken the certain amount divided by that is the riskless amount divided by risky amount, we got 0.83. So we are raising this number by, for year 2, raised by 2, for year 3, raised by 3, for year 4, raised by 4, year 5, raised by 5. You get this number there. Then arrange your years now. Year 1 to 5, riskless cash flows. You are taking those cash flows. Now, are we generating 45 million? Well, that is something that I should first check. Is that what we are generating? Are we generating 45 million? What are we being told in that question? Yes. We're being told the machine is expected to generate shillings 45 million annually over its economic life of 5 years. So we are generating 45 million. So that is where 45 is coming from. That is where 45 is coming. That is where 45 is coming from. So we are taking this 45 for these 5 years. We multiply by, for year 1, multiply by 0.83. For year 2, 0.67. For year 3, 0.57. I can see, I understand that you know what you are doing. The riskless cash flows. 45, this project is generating 45 million each year for those 5 years. Then you are multiplying by those figures that appears just up there. For year 1, we got 0.83. For year 2, which is just up here, this one here, 0.67. Year 4, 0.57, 0.47, 0.39. So you multiply that way. And then these numbers you are getting here, these answers which you have here, you'll be multiplying by present value interest factor at 4%, which is given by 1 plus rate raised to negative n. So here you'll be taking 1 plus 0.04 raised to negative n, negative 1, negative 2, negative 3, you get these numbers, and then you multiply this by this. For example, the first year, that's 7.35 times 0.9615, you get present values. Sum them together, and then you will less the initial capital outlay. The initial capital outlay, this machine cost 100 million, so that is what you'll be lessing, initial capital outlay. So sum all this. When you sum up the present value, you get 119.09 minus 100, you get 19.09. So the net present value is positive. The net present value is positive. Therefore, it is advisable for the county government to replace that machine or to buy the machine. Now, the other small theory there, advantages and disadvantages of CEC, certainty equivalent method. I think that is enough for that. That is quite enough for that. So I think that is well done. But something that I want to emphasize on, is this particular section here. What I'm emphasizing on is this part here. Understand here, for year one, what you'll be doing in year one, you'll be given a certain amount which you are very sure to generate. And this amount is riskless, has no risk. You'll be picking that amount, and then you'll be given another amount which you are not sure of. You divide by that amount you are not sure of. So this amount that you are sure of, we say it is riskless, has no risk. The cash flow that is probabilistic, that cash flow which you are not sure of, then we say it has a risk. So you start with year one by taking the amount that you are certain to generate, divided by that amount that you are not sure of generating. Then after that, when you go to year two, take the certainty factor of year one, the one that you have calculated here, raised by 2. You are in year 2. When you go to year 3, you take just the same figure here, you raise by 3. For year 4, you raise by 4, that way, that way, that way. That's the most important thing, as you have seen here in this question, whereby you were very sure to generate 181,347, but the 200,000 you are not very sure of. So you divide 181,347 by 200 and you get this figure. So this figure is will just appear here. For the others, you raise by 2, for year 3 by 3, for year 4 by 4. You have this column. Whatever is in this column, you multiply by the risky cash flows now. The 200,000 here. The 200,000, you multiply by that figure, and then you get riskless cash flows here. Then a column for present value interest factor, that is 1 plus rate raised to negative. These are that will be negative 1 raised to negative 1 raised to negative 2, that way. And then multiply this by this, you have this. You sum up this, if you sum up this, you'll be getting total present value, you less initial capital outlay. The project cost 500,000, and the answer will be the net present value, having incorporated the CEC, the certainty equivalent coefficient. Well, I think that is well captured. I think that is well done. But unless anybody has a question, And if you have a question, you can communicate through our numbers there 0727 87 1093. If you have a question, you can even write an SMS for any clarification or for inquiries concerning what we do, the kind of services that we offer. Uh, we have numerous services that we offer, such as tutorials, physical classes, tutorials. We also have online classes. We also have books, textbooks, study materials, revision materials. There are so many services that we offer, especially for students, among other professional areas like in auditing and assurance and taxation. So if you have any question that you have, my numbers are just there. So that question is quite elaborate. I like this question, the way it looks like, because it gives a student a very detailed way of dealing with net present value, incorporating CEC, certainty equivalent coefficient. So you can just go through that example, and then you look at the other questions that I have. I've given you those questions as your assignment, even though in your screen you can as well see the solution, so you can compare those solutions with what you have. Now that's enough for today. So we meet next class just in a while. Have a good day.